Is this on? Okay, yes, that's on. Now you know how long my password is. Okay, I have some demos. I like to do demos. All right. Oh, crud. Let me cancel. You'll have to forgive me. It takes a moment or two to get all of these states back up. While we are all waiting here, I want to thank everyone for staying this late. It is the last talk on the last day. You've had lots of food and drinks and everything else, and maybe a little bit sleepy, so I do appreciate you sticking around. I'm going to do some... Yes, I want to make sure there's no problems with the demos. That's really the last thing I want. Okay. Everyone is talking to everyone. Professional. Okay. This is, of course, Abusing Software-Defined Networks, Part 2. I had a wonderful event, Hack in Paris, number 6 here. Congratulations on number 6. My name is Gregory Pickett with Hellfire Security. I am part of our cybersecurity operations group. Started out in the defensive security end of things and then switched over to offensive security, which is what we're talking about here today. I think a lot of people do that. Right, to see things from different perspectives really helps to understand your opponent, to be your opponent. An overview of today's talk, we'll start out with our progress. All right, for lots of you, this will be new. You weren't here for part 1, so it helps to talk a little bit, just a little bit about what we were looking at the first time around. After that is, of course, using the SDN toolkit to continue the work that we started. Next is assessing controllers. It's pretty straightforward. After that is extending the SDN toolkit for new versions of existing controllers or entirely new controllers. They keep coming up with new ones. It started out there was just a handful, and now everyone has an SDN controller now for some new SDN product. And then we'll wrap up things like final thoughts, where to find the toolkit, because this is really about testing the SDN networks, testing them through the controllers, and so there's a toolkit, of course, to go with it. So we'll start off with the first presentation, kind of a recap. What we covered last time, and a lot of people cover, is the southbound and the northbound APIs. The southbound, of course, being OpenFlow. It is the most popular, although there are other protocols. They're using netconf on the southbound side. Northbound is traditional web services type APIs. And what we were looking at were a lot of the initial types of approach you take when you look at any sort of product, which first, encryption, right? Is this a secure product? Also then, after that, what's at that door that you're reaching? The authentication. And the two controllers we focused on were the two prominent controllers at the time, both of them open source, easy access, of course, then, so they're more popular than most products that are harder to get a hold on. That's Floodlight and Open Daylight. There were lots of problems with both encryption and authentication for both Floodlight and Open Daylight. Right? In the case of Floodlight, there was no encryption or authentication. Right? With Open Daylight, it was there but turned off, and it was lots of operational issues that allowed you to circumvent. And speaking of circumvention, Open Daylight had a nice XXE injection that I found and was able to share with the Open Daylight team. So lots of really, really fundamental problems with these products, with these controllers. And of course, this is nothing new. When something comes to market, really interested in features, not so much in security. So we were able to get them started on fixing that sort of thing. And what's changed in the last 2 years? Floodlight has improved significantly. Originally, I believe their response was, it's meant for a POC, it's meant for the lab. It doesn't have to be secure. And of course, that's not the impression that I got, nor a lot of people got when you read the website and they say, hey, use this to build your product. Use this to deploy this, right? And I think they kind of knew that I wouldn't say full of it, but they were fibbing a little bit in that area because lo and behold, security showed up, right? So there is encryption there is authentication there. Open Daylight was a bit different. It was a new project at the time, and they were basically formulating strategy, trying to get operational teams together. And so this was a nice wake-up call for them to move things up the list of priorities. So they have a very strong team now for incident response, for CSIRT, right, to respond to these sorts of things. And they were able to, once they got organized, to close that vulnerability rather quickly. And now what also has changed is not only do we have Floodlight and Open Daylight in the market, we also have a whole lot more controllers, lots of controllers. Okay. Now the problem, of course, is that there are more controllers, right? The toolkit is able to work with 7. There are so many more. Each has a different API, and of course, they're all special snowflakes. So there's really no easy way to test them. They're all very different on how they take their approach. And not only do we have a lot more controllers, we need to go much more in depth, right? We want to get the fundamentals down. We want to take care of the encryption and the authentication. But we have to look at the fundamentals inside the internals, right? How it's handling data. Is it handling it in a safe way? Can it be manipulated in some fashion, right? So we have a lot more controllers now, and we've taken care of the basics. Now we need to actually go deeper with all those controllers to go further, make sure that it's secure both inside and out. Okay. So did I jump? No. Okay. So the solution then is to make sure it's easy to add controllers. So when these new controllers come up, you're able to just go ahead and start testing them as you've tested other controllers. All right. So that means moving away from hard-coded solutions. And I will say that the initial release of the SDN toolkit was hard-coded. Floodlight and Open Daylight, right? So the idea then is to move away from there to a template-based system so that your tool is basically just interested in sending messages, right? So that all you need to then do to extend it is swap out a template that is able to then be sent to a different controller based on the different template. Also, partnering is rather important, all right? I'm partnering with Burp, and what this does in the SDN toolkit then go ahead and generate these messages and send these to these controllers via the proxy so that you can begin to use some of the tools that Burp has, right, with the repeater, with the intruder, all those sorts of neat tools that Burp has. Okay. So the SDN toolkit, I don't know if this is an obscure reference. I think by now it's a bit old, but it seemed appropriate at the time that I put this together. Okay. So what is the SDN toolkit? Right? It discovers, identifies, and manipulates SDN-based networks through both the northbound and southbound APIs. There's OAuth switch, OAuth flood, OAuth check, OAuth enum, OAuth map, OAuth access, and the new one, OAuth scan. All right, what does it do? It identifies OpenFlow services, reports on their versions, and determines endpoint. This is very much oriented toward testing. That is OAuth check and OAuth enum. Simulates OpenFlow switches and floods controllers. That is OAuth switch and OAuth flood. Right? Seems to make sense. Maps the network, identifies targets, builds ACLs, and locates sensors. That would be OAuth map. Adds and removes access. That is OAuth access. And with OAuth scan, we are now able to fingerprint and scan controllers. Problems this solves: SDN fingerprinting, SDN visibility, SDN accessibility, SDN testing, the usual authentication, but also looking at authorization, and really when you're getting further into the controller itself, validation. So with SDN toolkit, what's changed? Obviously before, as I've said, it was hard-coded. The northbound APIs were Floodlight and Open Daylight only. Now what we're doing is modifying it to use templates so that it can be used with any controller. Right, you just extend it, right? For new controllers, by adding to the config INI, right, there's a section for controllers, and then there's a section for each operation that you're going to be using with that controller. And then, of course, for each operation that you want to carry out, there's a template to go with it, right, for it to send. OFF-SCAN is the first to be programmable. The first thing that I ended up coming up with was the static flow pusher, which is basically what builds the message to add flows, to make changes to the controller. All right, OFF-MAP and OFF-ACCESS still speak floodlight and open daylight, and that's because the other part of that is a little bit harder, which is a programmable parser. All right, basically means you have to be able to tell this thing to read all sorts of different layouts for both JSON and XML. There's all sorts of nesting. It gets really messy, and you need a very clean, easy way to do that. And coming up with that is a little bit harder than just loading up a template and sending it as a part of a payload. OFF-MAP and OFF-ACCESS, though, will be ready soon. I came up with a much better solution than I had started out with. But that's OK. I'm here to talk about OFF-SCAN today. That's a lot of the testing is done through it. The bulk of the testing is done when you talk about going deeper. All right, so scanning. And you can obviously be setting up your proxy, and you run OFF-SCAN. You pass it the proxy address. OFF-SCAN will then iterate through all the different operations defined in that configuration file for the controller. Like most templating, replaces fields with default values, sends them to the controller through the proxy, and then, of course, you can utilize burp, the active scan, the repeater, intruder, to all the neat AppSec stuff, right? To play with that, to poke at that controller, get it to break. Now, and to give you an idea of what we're dealing with all the different APIs, I want to talk about the different controllers that are out there and how they're structuring their data and how they're sending their data, or how, I should say, how they're receiving their data through their APIs. So we'll deal with different interfaces, data points, and of course, covering testing methods, right? Test those APIs. And we'll go through the whole thing, right? So the interfaces, we'll talk about the exchange, which is just a delivery method. All right, there's RESTful APIs. There's RESTconf APIs. I'm not sure if you're familiar with RESTconf, but it's just basically a standard way representing and changing configuration data and system states. Right? It's not just a message and then you get a response. Instead, you actually have to load the data, then you have to trigger a state change, and that's what RESTconf is all about. Coming off course from netconf. Paths really is just what receives the message, which we deal with two types of paths. An operation path, which basically says I want to carry out this operation, and then some combine and say, this is the operation, and then this is my target. And of course, formats, which is just how the data is organized. All right, there's a lot of familiarity here if you've dealt with dealing with HTTP-based communication, JSON, XML. We also have identifiers, right? Each product has its own way of identifying basically the target of the operation. If you have a controller that comes from a traditional networking company, like HP, the identifiers are your forwarding elements, which are described as data paths and flows. If your SDN controller is from a company that is more traditionally in the data center, right, then what you're seeing is domains, virtual networks, and policies, and that's something like an open contrail. Cisco, of course, very Microsoft-like, wants to be different, and so they deal with tenants, networks, and contracts. They're very, very policy-oriented, much more so than open contrail. And then, of course, IDs. IDs, if you are dealing with a controller that is very flow-oriented, and that's, of course, in the context of more of a traditional networking company, the flow tables, which are kind of mapped in many cases to something akin to a database table, and so you'll find a lot of them using IDs, those that are doing that, to basically having, a key for that table record. Okay. Here's an example. This is Open Daylight. And I don't remember if it is helium or lithium. Of course, this is a new one, which is beryllium. They like their elements there. So we see the path there is using both operation and targets. And we see it using data path IDs, as well as record, table record IDs is also part of the target. And of course, flows, which is in the message itself. Right, so there's always these different combinations of these, how they organize this, and then what they're using for identifiers. Right? So time for the bug hunt. Right? Whatever you have, or once you've mapped everything out and you have a better understanding of the information you're sending, the type of information is required, and then how it's being received, then of course you want to poke at it. Right? Lots of different ways to test this. This is what we have time for today. I actually had this huge list: black box, gray box, white box, but of course we only have 45 minutes. So we're doing a black box, start to finish. My talks are very practical. So first step in any sort of engagement, whether it's for a customer, whether it's internal, a lot of this is oriented toward testing these sorts of controllers before you put them in your environment, because you want to make sure there are no surprises, right? There's a lot riding on that controller, a lot to lose if it's compromised, and so it's geared toward testing those sorts of things, making sure we know if there's going to be any surprises. All right, so fingerprinting controller, looking at the encryption strength, authentication checks, of course password guessing, time-consuming but necessary, looking at the session management, authorization scheme, and validation. All right, so fingerprinting controller, OFScan does that very nicely. Right. It's pretty straightforward there as well. Flat file database supports paths and authentication mechanisms. It's actually able to authenticate to the controller. Right? If there is a token, it's able to grab that token and use that for all subsequent messages that it sends to the proxy, so you don't have to do that. Nmap is mentioned for differentiating between versions of controllers. Case in point is Open Daylight. From the API perspective, helium and lithium look identical, right? But there is a way to tease out the difference, right? There actually a different set of ports are open on helium versus lithium. So if you are looking at a controller and you're fingerprinting it, and you have one of those situations where you are dealing with versions and from the API perspective, you're not able to differentiate between the two, a port scan can oftentimes make the difference, can tell the difference between one particular version of a controller and the next. And we'll do a quick demonstration. I have these queued up. All right, so I think you can see that, right? Everyone, yeah, that's big. All right, so it's -A there. Now, in this configuration file, as I said, it's basically a flat file database, and it has an entry for each of the controllers, including a default port, and it's actually going to go through all of those and try that, right, and see if it gets a response. And then, of course, in some cases, especially when there's a authentication involved, and something like a token, it's going to go ahead and making sure it has a token back before it confirms that. And that can take some time, especially if something is not actually there at that port. The connection has to time out. So it's an auto detect only. Does that even work? Oh, rolling me back. So auto detect only controller is HP version 2.x. Encryption strength, SSLIs and test SSL work really, really well. Usual, right, with these sorts of things. Does it exist? Are you being required to connect in a secure fashion? Type SSL or TLS in version, which is really important because they seem to be falling like dominoes. Looking at various issues that are found: Heartbleed, Poodle, Logjam, Bar Mitzvah, etc., etc. Gave this a little bit earlier in the year. At the time, I think Drown was the new one. Looking at cipher suites, making sure it does not accept cipher suite 0. Look at the different algorithms, making sure that there are no breakable algorithms in use or able to be used. For those that are toward that end, that are just weak and require a key strength to offset some weaknesses in the algorithm, make sure that those key lengths, those key strengths are available. Authentication checks, OFScan, right, for HTTP and login type authentication. I call these basic checks because there isn't much to it. Am I being required to use a password for this particular controller? If I am required to use a password, right, is the default password still there? That never happens. Another demo. So maybe too far back. There we go. So it's going to go through that again. That unfortunately, there is no memory. So it's going to have to look for it again, auto-detect, if you will, and we have to wait for that timeout to occur on some of those connections. Give it just a minute. There we go. So it is being required. That's good. And it says bad credentials. Didn't use any. So that's how we found that out. So now let's go ahead. And I should have that there. Where'd it go? There you are. All right, so I'm going to go ahead and give the default credentials, since I've already identified it as HP version 2.x, the default credentials, and see if they're still present. I'm also going to give it an address for the proxy that we're going to use, as well as a proxy port, and then, of course, the address to the controller that it's going to end up at. It's going to do that. I'm going to go through that whole list. I really have to add memory to this. And you see all the warning messages, of course, there, because I have not turned those off. All the Python stuff for the certificates. There we go. So scan is complete. That means, of course, then that the default credentials are still there. I use them. They're accepted. And so we know that there's a problem there, of course, right away. Password guessing, right? In the event you don't have the default credentials, password guessing is, of course, important. HTTP, basic and NTLM, you can go ahead and use Hydra. It works great for that. It will work great here. If you're talking about a login, authentication, OFScan and intruder, go ahead and password guess that way. And, of course, while you're there, to make sure that there's some sort of lockout. Hopefully there is. And it's very easy to see that as well. I ran that through the proxy that time so that we would see all of these things here. We can pass this over to intruder. All right. And we can take that out right there. It gets that from its auto detect. You can put in one of the users there. Default domain, which is SDN. All right, leave that there, your payloads. All right, passwords, and then, of course, start that attack. All right, and you go through that. See if you can't password guess that. With a better list, of course, than this. Okay. Or AppSec. Okay. All right, authentication checks. You're dealing with certificate-based authentication. OpenSSL and SSLIs. Call it expanded checks because there's a whole lot more to do involved. Making sure, of course, that as a client, you're required to have a certificate. You use OpenSSL to generate your certificates and then hand them to SSLIs to utilize. Make sure that controller is checking for the expiration, right? Generator certificates that expired. Make sure that is checking the subject to make sure it's valid. See if you can't impersonate someone else, impersonate another system there. Make sure that it is checking for their impersonation. Another system that has a relationship. Okay. Session management, OFScan again. Right? You're proxying through a burp. Once you have the analyzer, the sequencer there, you can go ahead and grab all those tokens and you put them into burp to analyze. And go ahead and close that window there. And of course, we're going to send this over to repeater. Pull that out, of course. Put in those default credentials we know are still there. I don't know where they came up with Skyline. Okay. There we go. And you just copy that. I think that scripting would really be helpful because it wants, I believe, 100 of those things, right? And of course, cutting and pasting would not be fun. Right, so go through and you collect all those and you can run the analysis. All right, so authorization scheme. OFScan does a very basic check because it uses the default domain. All of the controllers have default domains or some sort of default table that is there. And so you can check to see if you are able to add and remove flows using OFF-SCAN. For more expanded checks, you can use OFF-ACCESS. That would require some information gathering, either through OFF-MAP or through man-in-the-middle. See if you can't discover other domains, right? And go ahead and try different data paths, different domains, and different tenants, and see if you're able to, if you're authorized, right, to go ahead and make changes there as well. Validation. OFF-SCAN, all right, running that through burp again. Test it. Once you've got it there, test with active scan. Use the repeater, do manual testing, and then, of course, intruder for some fuzzing. I'm going to show you something about these controllers right now that is quite, well, the problem is quite prevalent. I'm going to run owners through the active scan. Yes, of course, I'll expand the scope. I hate Windows 8. Just have to say that. All right, so it's going to go through there. Should have something rather soon. Cross-site scripting reflected. It comes right back as it was sent. Okay. So that's cross-site scripting, reflected cross-site scripting, and that's common among the controllers, including HP. And then I'm going to go ahead and push this over to repeater because I want to show you one real quick thing here. So if we try this, all right, you can see this error message. Now, this error message actually shows up in the controller GUI. The only reason why it doesn't spring, right, doesn't launch and start executing is because it's being retrieved with AJAX. Right, as a JSON file, which means it's not going to be rendered. But that, of course, leads me to think, where else is this showing up? Is there anything else in this controller that is not using an AJAX call and not getting something as JSON, something that actually may be treating it as HTML? So this is, I think, something that needs to be looked into further by me, by you, by anybody, to see where this thing is floating around, where else this is consumed. Does it hit syslog? Is it going out to another application where it can be read in a non-AJAX fashion, where it can be sprung on an administrator someplace? This is, I think, maybe even epidemic to say in these controllers, where so many of them, they don't sanitize. They don't really take the perspective that there's a risk here. They have something in place, maybe like Django, right? They have something here where they're doing calls with AJAX. And so you think there's not a problem, but when you have data like this that is dangerous, that has floating around, you really don't know where it's going to come up. So you don't know if there's going to be something like an AJAX call protecting it. You don't know if there is going to be Django, a Django like a framework like Django, keeping it from springing a trap there on somebody. And we can get one more thing here. I want to show you the stored part of it. And there it is right there, stored away. So, stored cross-site scripting right there, or persistent. All right, so that stuff just floats around in there. Okay. All right, so testing considerations. All right, exchanging messages. Check out those replies from the controller. All right, they're very informative. Adjust for the feedback that you're seeing. It's going to happen a lot initially when you start developing your own templates because there's going to be minimum requirements. There's going to be different data points that the controller is going to require, and you want to make sure that they're included when you build a template. Look for unique and revealing error messages. Data being returned unfiltered, like we saw with the HP controller. Okay. Manual approaches to this stuff, right? It's inappropriate data types, different character sets or symbols, data sizes, out of index. I don't remember if it's HP. I think it's maybe HP where there is a maximum table size of 255 records, right? HP, I've already tried more than 255. That doesn't work. But anytime you're seeing any sort of identifier that involves an index like that, push it out of bounds. String lengths will be probably impossible given that a lot of these are based on Java. Injected single and double quotes, anything AppSec. I'm actually a network guy that got forced. That's why I got started on software-defined networking, but then I got forced into AppSec. So it pains me to say this, but yes, anything AppSec, because once it is software-defined network, right? Software apps, once you get there, treat it like an app. Right? Anything that you can do to poke at it, to break it. Okay. The SDN toolkit has 7 controllers currently able to work with: Big Switch Fabric controller, Open Daylight, Brocade SDN controller, HP VAN, Open Contrail, Open Network Operating System, Cisco Application Policy Infrastructure Controller, APIC. Adding new controllers is pretty straightforward with the controller section, the operation section. There, we'll cover that as well as the section syntax and the minimum requirements for adding onto that. Okay. There's our sections there. There's one each under the controller, section for each controller, that is used to, of course, identify the controller to the toolkit, as well as what it uses for auto detection and any particular operation that you want the toolkit to carry out with that controller. Under the operation section, breaking that down, there's an identifier for that particular controller, friendlier name, the default port for the controller, the method that you're going to use in the auto detection, the path, the format. That's for the HP there. The headers that are going to be used, content type, except login, which actually ends up being the XAuth header. Of course, template name. If there's a login requirement for the controller, place the template there. That's what we're going to use to attempt to log in. And of course, the token name. What I'm going to look for as far as the reply to verify that I was successfully authenticated, and then I can use, of course, that token for all subsequent messages that are pushed out to burp. So you have one of those, and then for each controller, you have a number of defined operations. There are just a couple or handful in here, but you can add a whole lot more, because if you go through the documentation for any of these controllers, there's 20, 30, 40 different operations. And you can add and add and add all the different type of operations so that you can push all of those messages for the operations through burp to test the controller, try to break it there with that operation. Okay. Minimum requirements, you of course have to have that controller entry. And then there are 4 different entries used there. They're basically system entries, system operations that are used by OFMAP and OFAccess. List flows, add flow, allow traffic, drop traffic. List flows is used primarily by OFMAP. Add flow is going to be more of a free-form entry, allows you to define the operation. If you know much about OpenFlow, you can actually make transformations to the flow itself. You can change packet values, you can send the packet somewhere else, or you can redirect it somewhere else. That's more for free-form, and that's used by OFAccess. Basically, all sorts of different operations you can carry, or not operations, but transformations you can carry out on that flow as part of a flow table record entry. And of course, allow traffic and drop traffic, which are used by OFAccess, as well very much modifying ACLs, what you're allowed to do, what you're not allowed to do, or go on that network. So those are basically system entries for operations that OFMAP and OFAccess need to carry out. For templates, it's a text file of that expected message. It's gotten from the API documentation. It's used by both auto detection and for the operations. There's sample values in there, of course. When you go to the documentation, you'll just replace them with the fields. Toolkit then replaces those fields with your values and then sends them off to that controller. Okay. There's one of the templates there. This is going to be, I think, allow traffic. I think that, yeah, allow traffic. So we have some of the samples there. I totally ripped off HTML there with the greater than, less than. You have me on record there. Priority is one of the fields, network source, network destination. And then this is one of the instances for allow traffic. It is system. It just has whatever the value is for that particular controller. Output normal is what that uses to allow traffic. Then we have one Open Daylight. This is for add flow. I think that's the name. And you can see this one uses the number as an identifier. We also see the fields network source, network destination, flow name there as well, part of the template. Available fields, these are all the ones that you have there. And names don't have to match. When you're looking at building a template, just find the equivalent. And you don't necessarily have to use all of them. They're all there in case you might need them for that particular controller. You just place what you can. Right? I jump right to the end there. So the final thoughts for all of this is that standard attack tools still work under an SDN. It is ultimately software. Controller presents just an additional attack surface. Visibility, accessibility, and testing is difficult, though, with these sorts of things without prior knowledge. We're not going to prevent that. You still have to go out there and research the controller, but the idea is to share that information. You do it once, you instill that into a template, and then you go ahead and you can share that, or you can use it over and over again with yourself, with other team members, other people out there. And the idea is to attack the controller the same way you would then an application. It's important that we keep the vendors accountable, because this really is about making sure that if you're deploying SDN, and I think at some point in time we're all going to have an SDN product in our environment. They're, of course, arguing about what actual definition of software-defined networking is, but it's something that is coming. And if it's something that is going to be in your network, you need to make sure that it's safe. The vendors aren't necessarily doing that, and it turns out right now that they aren't doing that until we put pressure on them. So this is something for you to test that SDN. If you have to put it in that network, you have to know what you're dealing with. You have to know your risks. I'm using the R word. I generally don't like GRC myself. But it's important to know those risks so that you can do all the different things, these different compensating controls, mitigating controls, at least know what your exposure is so that you can then report that to the vendor. And, of course, make sure that your next generation network is safe. Toolkit, I'm a little old school. I'm still on SourceForge. But you can get the latest version there, 1.2.1 for OpenFlow networks. It'll be up later today. All right, some links. There is one up there that's really nice. There's not a lot of resources out there for testing APIs. So this is more of a general resource for testing APIs. And then, of course, down the line, we look at REST assessment, there's a cheat sheet there, and there's all sorts of documentation on the various controllers out there. Okay? That is everything.